mois maintenant, on a notre ami Lucio Guerra. Pour ceux qui sont des réguliers de Final Cut Montréal, il est déjà venu. On avait donné une belle formation sur la HVX 200 il y a quelques années. Puis Lucio nous avait aidé à rendre ça possible. Alors, Lucio Guerra de Panasonic Canada qui va introduire notre présentateur de la soirée. Merci beaucoup, Lucio.
Merci, Marc-André. Alors, merci pour être venu ce soir pour nous entendre parler un petit peu de qu'est-ce qu'on a. Alors, René vous a parlé un petit peu de la technologie. C'est un gars qui connaissait ça pas mal. Notre raison d'être ici ce soir avec Panasonic, c'est pour vous montrer comment est-ce qu'on peut faire du 3D à un prix un petit peu plus abordable et avec plus de facilité qu'on a l'habitude d'avoir connu. Je ne sais pas s'il y a d'entre vous qui ont déjà vu ou entendu parler ou lu sur le 3D, qu'est-ce que ça prenait. Aujourd'hui, Panasonic a introduit quelque chose qui coûte beaucoup moins cher pour faire du 3D et qui est plus facile à faire aussi. Alors, j'ai avec moi le plaisir de vous présenter David Craig, qui est notre gérant de produits pour Canada. Et la présentation va se faire en anglais. Si jamais vous avez des questions, moi, je peux faire la traduction en français. Alors, je vous laisse avec David Craig.
I'm going to wander around a little bit. We're going to try and make this fun for you, and we're going to try and make this simple. What Renee said sounded very complicated to me. It was very complicated. Let's do this while we're waiting. I'm going to do this. This little bit here, and it really kind of sums up some things. Are you all ready?
Because everything is amazing right now, and nobody's happy. Like, in my lifetime, the changes in the world have been incredible. When I was a kid, we had a rotary phone. We had a phone that you had to stand next to, and you had to dial it. Yes. You don't realize how primitive, you're making sparks in a phone, and you actually would hate people with zeros in their numbers because it was more, like, oh, this guy's got 2 zeros, screw that guy, why do I want to... And then if they called and you weren't home, the phone would just ring lonely by itself.
So, you know, everything is really amazing and no one's happy. When I started in video, Renee, you can help me on this. Videotape was this big.
I'm much younger than you.
Yeah, right. Yeah, you are actually. Now, we have high definition on a little card. This is magic to me. This is amazing. And someone says, can you make it longer? Can I get more on there? They're not happy. Let's have a look at something else I quite like from this man, too. And this is so typical.
Do you feel that we now, in the 21st century, we take technology for granted?
Well, yeah, because now we live in an amazing, amazing world, and it's wasted on the crappiest generation of just spoiled idiots that don't care, because this is what people are like now. They got their phone, and they're like, it won't... Give it a second. It's going to space. Can you give it a second to get back from space?
Am I right? Damn, why doesn't this computer work? What? Get a bigger hard drive. We just did that today. We just bought it. We need a bigger, faster hard drive. We went to the Apple store. We got a bigger, faster hard drive. Renee touched on a lot of things today that I was going to touch on. So I bet you if I come in front of those speakers, it's going to feedback, right?
Try it.
No, that's okay. I like to be close to my crowd. We all talk about 3D, and 3D's been around for a long time. And I like to ask the question sometimes, now we think 3D, but we also have to remember that 3D today is also HD. Like, it's not just standard def. You can do 3D in standard def, but today's 3D is high definition. Anybody know when the first high definition television broadcast was? First high definition television broadcast. Anybody got an idea when that might have been?
Discovery Channel.
Discovery Channel. Good guess. Wrong.
2005. BBC.
BBC. Why do you say the BBC?
First broadcast in HD?
Yeah, why BBC? In 53. I thought they were still in black and white in 53. I like his answer, though. He got off the continent.
Au Japon, des années 80.
No. Everybody give up? I'll give you a hint. It wasn't in this century. It was in the last century. It was 1936. You're all looking at me. Those Anglophones are crazy. Okay, no. 1936, the BBC announced the world's first high-definition broadcast. Yes, you just believe. He says, you're a crazy man, right? All right. 1936, they announced the first high-definition broadcast, and it was 405 television lines. But to them, that was high definition. What's high definition to you? What's high definition to you? What's high definition to you? Is it watching ABC at 720p, PBS at 720, TQS at 1080, CTV at 1080, CBC, hard-pressed to broadcast in FM stereo, let alone high definition, but they do it occasionally. So it's all a matter of perception. To me, high definition, and I hate to say this to my Panasonic bosses, so I'll turn the chip off so they can't hear me, is IMAX. Do you agree, Renee? IMAX is pretty high definition, isn't it? It's film, but it's high definition. So different definitions mean different things to different people. So now we've got 3D. And let's see if technology fails me. Let's see, this thing hasn't worked for a while. Laser pointer works. So there's 3D. Anybody remember what these were called? English or French, doesn't matter. What were they called? Stereoscope, stereopticon in English, yes. They've been around since, well, the first 3D film was 1888. This has been around before that. You can still buy those. I bought one in Paris, France, in a junk shop this summer, a little picture of France, and it was a 3D card. And I looked at it, crossed my eyes, and what? Voila, it is 3D. Couldn't get my eyes uncrossed for 2 days, but it was 3D. I'm just going to move this a little forward so I can not have to walk back. So for those of you in the back row, you can cross your eyes and you can see a beautiful 3D image. Pretty simple stuff. They had camera, it had 2 lenses, you have 2 eyes, it works. In the 1950s, the golden age, as your slide said, the golden age of 3D came, saw, died. The Creature from the Black Lagoon, what was it? Was a bad movie to begin with, okay? Let alone in 3D. But people came out to the theaters, and why in the 1950s did we have 3D? Anybody know?
Because the movie, if cinema was just going down.
Why?
Everybody was buying
TV, exactly. So the television, or the film producers decided to bring out 3D, widescreen, the first CinemaScope, Cinerama. But 3D died because you had to put these goofy glasses on. These are like welding goggles as far as I'm concerned. Look at through that. That's like a welding goggle. Look at it. That's dark. Yes. And the CBC, technology giants that they were, they broadcast that Queen coronation thing with these glasses. And I got these free at Canada Post. And so I watched the thing on 3D, on the CBC, the Queen. Anybody here see that? Put them on, put them off, put them on, put them off, put them on. You said that, right, Renee? And it was interesting to watch in that the 3D through these little colored glasses was pretty bad. But it worked. And that's 1950s technology. And the thing was that someone had the vision to shoot the Queen's coronation in 3D. 2 16mm film cameras, side by each. So that did not have to be shown on the CBC with red and green glasses, or in this case, blue and amber. They're also good for watching the eclipse of the sun. So I'll get on to some of that a little bit later. We talked about 3D. Pirates cannot see 3D. All right, they have a patch over one eye. They need 2 eyes to see 3D. There are some people with 2 very good eyes that still can't see 3D. They just don't have the capability. And where is 3D formed, as Renee said? Right here, in your brain. It's your brain that gets the images and fuses and creates the 3D. So we need 2 eyes, and we need 2 cameras. So we have the side-by-side rig. I believe in French it's rig. And then we have the mirrored type rig as well. And they are the way that we shoot today, whether it be 16mm film, the one that the Queen documentary in 1953 was shot with a side-by-side rig of 16mm cameras. Today we could use video, we can use 35mm, we can use IMAX, we can use little wee cameras, you know, little miniature cameras. It's still the same thing. We still need two images. We need two eyes to see that. So the beam splitter is an interesting way because you can actually get the cameras in physical space. You can get them right close side by side because your eyes are about 65mm apart. Well, I've seen some folks with wider eyes and I don't know. But they're about 65mm, 2.5 inches apart. And so you need to get the camera about that far apart. Well, that's very difficult when you get a big camera and a big lens to get that close together. So the beam splitter works very well at getting them close. And that's kind of the standard, quote unquote, that we shoot with today, whether it be a Panasonic high definition camera in the rig or some other brand. There are other brands, aren't there? No, I didn't think so. So the rig is a wonderful way of shooting, but it's got its problems. First of all, we got two cameras. Well, we got to get the exposure right on both of them, and that's going to look pretty funny, isn't it? We have to have the zoom in exactly the same position, the focus in exactly the same position. And if we change any of that and do a follow focus, I got to change the lenses both at the same time. I can't even walk and chew gum at the same time, let alone do that. So changing the iris, the focus, the zoom simultaneously requires some sort of fancy electronic device, and the lenses have to be matched at manufacturing. It gets expensive. Anybody have any idea how long it takes to change lenses on a 3D rig between shots? 20 minutes. 20 minutes. How big is the crew that works on a 3D shoot? Typically. Well, more than that. It takes about 5 or 6. Yeah. So they're a great way to shoot, but it's complicated. Make a good title for a movie. You must manage the parallax. The camera lenses physically do this. They move in and out. This is where the audience gets to play, and I get to laugh at what you look at. Take your hand and put it up like this in front of you. Okay? And focus on your hand. You really look stupid, you know that. So you look at your hand. All right, now leave it there and focus on something far away. What happened to the hand?
2 hands.
2 hands. You got 3 hands? Right, do that again. You focus on your hand and then focus on the distance. What did your eyes do? They moved in. They moved in to catch the hand, and then they moved a little bit out to do the focus. We do the same thing with a camera, and we call that convergence. I'm going to converge my eyes on you, because you're trouble. I'm going to keep my eye on you. So I've converged on him. We're going to do the same thing in 3D. We're going to converge on an object. And when we do that, we take the cameras and their field of view crosses at that spot. And that is what it'll appear when your glasses, it'll appear to be at the screen. Anything behind where I've converged will appear inside the screen. Anything in front will appear where? Popped out in front. This is easy, isn't it? This is pretty. You're doing that again, aren't you? I can see some of you. It's good. So, if the camera lenses are too close together, then you've got no 3D effect. If you have them too far away, it exaggerates it. People begin to look like one of those kids' pop-up books, and it just looks unnatural. So you can't have it too far away. It will exaggerate, and in some cases, it's painful to watch. Not only hard on your eyes, hard on your stomach. Makes you sick. So there's some things you have to keep in mind when doing normal 3D with the rig. Oh, there's another little slide, and you'll see this thing convergence come up over and over and over again as I go through this tonight, because it's kind of important. So to get really good 3D, we have to not only have the lens matched, we have to have the focus matched, the iris matched, the white balance matched, the lenses matched. Everything has to be. Oh, and then there's the issue of we've put it in a mechanical device, so one camera can't be slightly tilted, or you're going to have an image like that, the rotational error. And then you're going to have one that's maybe just a little higher than the other. Oh, no, that's no good, because you're going to get a vertical error. And I loved your slide, Renee, that said Sony is proposing a device to correct that. And I said to Lucio, I said, proposing? We built something that corrected that. So Panasonic, I'll show you that. So to get good 3D with a rig takes a lot of skill and a lot of technology. It's getting better, but it still takes a lot of manpower, person power, to do that. So the question is, it's all optical, it's mechanical, it's expensive, and it's not necessarily possible to get good 3D. Post-production, yeah, we can fix it in post, but every minute you spend in post costs you, lots of dollars. So I don't want to spend a lot of time in post. So we wanted to, can we scale this system down? This is what Panasonic engineers said. We want to make this simple. Can we scale it down to become more manageable? Can we do it with a 2-person crew, or ideally, 1-person crew? Well, we all know the answer, don't we? Yes? We? Okay. Oh, that's the last slide. No, it isn't. We made the Panasonic 3D A1. We took basically 2 side-by-side cameras, put them in together, matched everything, controlled the lenses together, all in one little package, which we brought with us tonight. So the 3D A1 is what we did for mini DV a few years ago, and for HD in a compact camera, we've now done for 3D. There's the camera. 2 lenses, 2 cameras, 6 imaging chips, 3 for the left, 3 for the right, all in one little package. And it doesn't weigh much more than our previous portable cameras. It does seem to get heavier at the airport on Friday nights. I don't know, the whole bag seems to get heavier by Friday. So it's lightweight, it's compact, it's easy to use, it's high definition, obviously, and it's 3D. And more importantly, it's really easy to use. Did I hear someone spot the price over there? Yeah. All right, let's price out a rig. Yes?
Vous en faites tirer, I don't know how to say it in English, you make a ruffle? Vous en faites tirer une?
Oh, is it a door prize? I'm sorry, we drew the number a while ago. You weren't here. Yeah, it is $22,000. Let's price out a rig. Anybody want to do that? Now, we're not saying that Panasonic 3D A1 is going to replace rigs. Far from it. They're still going to shoot features, sports, with rigs. What this does is brings 3D down to a level where you can rent it inexpensively. A production company can purchase it way less than a $150,000 to $200,000 rig. And they can learn about 3D a whole lot faster and cheaper than they did before. So the camera is completely assembled. The lenses are built and assembled together. They're locked together. The servos are together. The irises are together. The zoom mechanisms together. Everything in that camera is locked together. All right, let's look at the camera. There's the usual ones, the iris, the focus, zoom, and white balance. Getting your talent, which rarely is, to hit their mark. So that's the hard part of the shoot. Just got that now, didn't you? Well, they really are. Talent really is. So that's the easy part. Iris, focus, zoom, white balance, talent, set, lighting, set decoration, art direction. There's one more thing to do with this camera. Just one more thing. That's all. Convergence. Remember? We converged our eyes on our hands. So there's one more little dial on this camera called convergence. And convergence, again, is where is something going to be in 3D space? Is it going to pop out in front of the screen? You know, the typical spear coming at you? Or is it going to be in the background, hidden deep inside the screen? Hi, Chris. So there's a little dial here, and that's called convergence. Well, so what, you say?
What is the closest distance you can converge for a close-up?
It's a good question. Can I hold it for a few seconds and come back to it? Because it's a good. The question was, how close can I converge? Let's do a little test. Can you converge on that?
No.
You converge on that?
Yeah.
You're better than me. Okay? There is limitations to how close you can get with a 3D camera before it starts to hurt your eyes and the audience's eyes. And that's about 1.2 meters is about as close as you can get. But not only is there a convergence, remember there's just one more control on this camera, just one. So you can now push the 3D guide button to help you with convergence. Because let me tell you, out in the field, I want all the help I can get. Because it's cold, it's miserable, it's raining. Oh, wait a minute, I was in Toronto, sorry. So in the field, I can look in the viewfinder and see this incredibly unsharp, fuzzy-looking picture. What the heck's gone wrong with that? What are you seeing there? I've pushed the 3D button to help me, and what am I seeing? I'm seeing my battery, I'm paused, I'm seeing 90 minutes, but I'm also seeing something else. I'm seeing a double image. I'm seeing both left and right camera images simultaneously. And I'm seeing a little guide right here that says my 3D is going to be useful from 3.3 meters to 8 meters. I'm safe if I keep those distances. If I don't, then I'm going to bother my viewer's vision in 3D. It's not going to be pleasant. The second time you push the button, it gives you a little green 3D, and that's for large screen. So if the video that you're doing is eventually going to go to a large 30-foot screen, the convergence is different for large screen than it is for small screen. So it really helps you to know whether you're going to big screen or small screen, and that's where this camera, it gives you a small screen convergence safe zone, and it gives you a large screen.
What's the range?
I'm sorry?
What's the range for a small and a large screen?
What is the range?
What do you consider a small screen?
They go up to, we consider small screen up to about 65 diagonal inches.
And minimum?
Down to a computer screen.
My iPhone?
Yeah, computer screen. Yeah. Now, in the viewfinder, you can just turn off one camera lens, just turn off the one image, and just look at, say, the left eye or the right eye. Because I don't want to go around looking at double images all day. That's bad enough after the bar closes. So just look at the single image. But when I do turn on the double image, I get the two images. And when something is converged, the double image comes together. So I know that when I have no shadow or no double image, that's my convergence point. So what's the benefit of seeing this in the viewfinder besides knowing where the convergence point is? Big deal. Anybody got an idea? When I got this camera in May, I got this is the sample camera, pre-engineering, not even beta software, pretty rudimentary hand-built sample. It did not come with a giant course from Japan on how to use it. It came with me sitting at the cottage one weekend, looking at it going, okay. And I went out and started shooting. And I did not need a 3D monitor to go shoot in the field because I had my double image. I knew exactly where my convergence point was. So I knew at the convergence point, the image would appear to be at the screen, and anything behind that convergence point would appear to be inside the screen or popped out in front. So many people say, well, how do I take a 3D and my glasses with me? You know, I'm ready to shoot. I've got my glasses on. Well, you really don't need them with this camera in the field. If you're out shooting a documentary and you're up in the wilds of Baffin Island, You're not going to be lugging around a 3D monitor. If you are, you got a bigger budget than any of us. So this is really helpful to tell you where your convergence point is. There's also a wonderful little application for the iPod. Sorry. For the iPod. And this comes from a Canadian company. Yay. Okay, thank you. From a gentleman by the name of Tim Dashwood, who runs a company called Dashwood Cinema Solutions. And we'll hear a little bit more about that shortly. And this is a little calculator for an iPhone, iPad, iTouch, sorry, or whatever. And it tells you, depending on what your zoom and what your convergence point is, whether your image is suitable for what screen. So it's telling you, what's my convergence? The little number C15 is a duplicate of what reads out in here. The convergence goes from 0 to 99. So you say, okay, I'm at 82, and my zoom is at 10. I'm okay. It also tells you when you're not okay. So it's a nice little application that goes along with the camera, but you don't necessarily need it. And there's a selection, you'll see, you asked how small the screen could be. There's a selection there for desktop image, home up to 65-inch diagonal, or theatrical 30 feet wide. So. The camera records, it has its own recording mechanism, and it would be pretty stupid if we had a camcorder and we didn't have a quarter part of it. So it actually records on SD memory cards. These amazing little cards that I think are just amazing because they carry all that information. So it records on, yes, 2 of them, one for the left and one for the right. And it records in the format of AVC HD. That's a format that was developed by both us and our competitors. And that's sort of like brothers and sisters getting along, but we did. We developed this AVC HD, and you can find it in everything from a simple camcorder that you'd buy for taking pictures of your kids, all the way up to our Pro Image cameras. So this camera records on those cards. Someone says, well, I want higher quality. I want better recording. I'm going to be doing green screen. So you could output from the camera via its 2 HD SDI outputs. And you could record on P2, on our little card recorders, or you could use something like a nano flash, if that's what you prefer. So the camera will output dual stream HD SDI, left and right eye. So that's kind of handy too.